All right, today we're diving into a new AI framework called PaperBanana, and it tackles one of the most, let's be honest, frustrating and hidden parts of doing scientific research, making all those diagrams that go into a paper. Let's see how it works.
So let me ask you a question. When you picture a scientist hard at work, what do you think takes up most of their time? Is it running the big experiments, crunching the data, reading through mountains of other research?
Well, the answer might actually surprise you. For so many researchers, it's the incredibly slow, painstaking process of creating the diagrams, the figures, and the plots they need to actually show people what they've discovered. It's a massive time sink that stands between a breakthrough and getting it published. So to solve this, a team from Google and Peking University created PaperBanana, and they had a really smart insight. They realized that making a great scientific diagram isn't one skill, it's a bunch of them. You have to understand complex text, plan a visual layout, nail the right style, and catch every tiny little error. A single AI model just isn't going to cut it. So instead of building one tool, they built an entire AI team.
Yeah, the real genius of this system is that it's actually 5 distinct specialized AI agents all working together. Each one has a very specific job, and they pass the work from one to the next, kind of like a real-life design team.
So let's meet the crew. First up, you've got the retriever, which is basically the librarian. It goes out and finds relevant examples to get the style just right. Then there's the planner, who's like an architect, turning the technical jargon into a detailed visual blueprint. The stylist is the designer, making sure the look and feel is perfect. The visualizer is the artist who actually creates the image. And finally, you have the critic, a super sharp-eyed editor who inspects everything for mistakes.
And you know, like any good team, they've got a playbook. PaperBanana's whole workflow is split into this really structured 2-phase process, and this is what ensures you get a high-quality, accurate result every single time.
So phase 1 is what they call linear planning. This is where the first 3 agents work one after the other. The retriever, our librarian, finds about 10 reference images, then the planner, the architect, creates that detailed blueprint. And finally, the stylist sets the specific color palettes and layouts to match what they call the NeurIPS look, which is a major AI conference. It's all about getting that professional academic vibe.
But now we get to phase 2, iterative refinement. And this is where PaperBanana really shines. The visualizer makes a first draft, and then the critic goes over it with a fine-tooth comb, looking for any and all errors. The critic then gives super detailed feedback, and the visualizer regenerates the image based on those notes. This whole loop repeats 3 times, polishing the diagram to perfection. That feedback loop is the absolute key to getting such high accuracy.
Okay, so the big question is, does it actually work? How well does this AI team perform in the real world? To find out, the researchers built a custom test using 292 examples pulled straight from actual papers submitted to that top-tier NeurIPS conference. I mean, this is a seriously tough, real-world challenge.
The results were really impressive, but this one number just jumps off the page. PaperBanana showed a massive 37.2% improvement in conciseness. Now, what does that matter? Well, it's not just making pretty pictures. It's making them clearer and better at communicating complex ideas fast. And that right there is the whole point of a scientific diagram in the first place. And it wasn't just a one-trick pony. It pretty much beat the old methods across the board. The overall score shot up 17%. Readability was up by almost 13%, and it even scored higher on things like aesthetics and being faithful to the original text. It was a clear, decisive win.
Now, I want to show you a particularly clever strategy PaperBanana uses to deal with one of the absolute toughest challenges in this space, creating statistical plots that are perfectly precise. See, the main problem with using a standard AI image model for data charts is this thing called numerical hallucination. Basically, the AI can create a chart that looks totally legit, it looks beautiful, but the numbers are just plain wrong. The labels on the axes could be off, the data points might be made up. For science, that is an absolute deal breaker.
So PaperBanana has this genius workaround. Instead of asking the visualizer agent to draw a plot, which is risky, it has it write executable Python code using a library called matplotlib. Now this creates a really interesting trade-off. The plot that comes from the code might not be as flashy or creative, but its data is guaranteed to be 100% accurate. This trick completely wipes out hallucinations and makes sure the final plot is scientifically sound. But there's another layer of intelligence baked in here. The system is smart enough to understand that different fields of research have their own visual languages, their own aesthetics. You know, a diagram for a computer vision paper just shouldn't look the same as one for a paper on optimization theory. So for example, when it's creating a diagram about AI agents,
PaperBanana goes for this illustrative, almost friendly style with cute 2D robots and chat bubbles. But for something like computer vision, the whole style shifts to be more spatial and geometric. It'll use things like camera cones, ray lines, and point clouds to represent 3D space.
And this same idea applies everywhere else. For generative models, it'll use this modular, flow-oriented style with 3D blocks representing data. But for really heavy theoretical work, it defaults to a super minimalist textbook look with a simple grayscale color scheme and clean nodes. It's a deep understanding of academic context.
Okay, so let's zoom out from all the technical details for a minute. Why does all of this really matter? Because automating diagrams isn't just about convenience. It has the potential to fundamentally change the actual pace of scientific discovery.
When you get right down to it, the core value is this. By automating one of the most tedious, time-sucking bottlenecks in the entire research process, tools like PaperBanana can free up countless hours for brilliant people. It lets them focus less on being a graphic designer and more on what truly matters, the science, the ideas, and finding that next big discovery.
And that really leaves us with a fascinating final thought, doesn't it? What new frontiers are we going to explore? What amazing breakthroughs are we going to see when the world's scientists can spend less of their precious time drawing and a whole lot more of it discovering?